In the Solve It, you may have noticed that multiplying both sides of an inequality by a negative number affects the inequality symbol. So that leads us to this key concept: multiplication property of inequality. In words, we can read it as, let a, b, and c be real numbers with c greater than 0. If a is less than b, then a times c is greater than b times c. And if a is less than b, then a times c is less than b times c. These properties are also true for inequalities that use or equal to, which will make a little bit more sense when we look at the diagram here. Again, a, -2, b, 3, and we're multiplying both of those values by a +2. So our -2 becomes -4, getting increasingly positive or farther to the left on the number line. And our 3 gets multiplied by 2 and becomes 6, getting increasingly positive or farther to the right. So what if c is less than 0? What if we're multiplying both sides of an inequality by a negative value? That's what this addresses. Let a, b, and c be real numbers with c less than 0. If a is greater than b, then a times c is less than b times c. If a is less than b, then a times c is greater than b times c. So notice what happened is we multiplied both sides of the inequality by a negative, and the sign flipped direction. We can see that in the diagram. For a equals 3, b equals 1, and c equals -2, when we multiply 1 and 3 by -2, here's the behavior. 1 becomes -2. 3 becomes -6, which is farther to the left on the number line, or less than -2. This leads us to problem 1, multiplying by a positive number. What are the solutions of x divided by 3 is less than -2? And graph the solutions. So remember, our first objective, isolate x using inverse operations. Currently it's x divided by 3. The inverse of dividing by 3 is to multiply by 3. We do that to both sides of the inequality, just as though it were an equation. We find that x is less than -6. Open dot at -6 and an arrow pointing to the left. Your turn. What are the solutions of c divided by 8 is greater than 1/4? And then graph those solutions.